Hey all, in the previous lesson we talked about parallelograms and we talked about the properties and then applied them to some situations using some equations. Here we're going to talk about special parallelograms, so they still have all the same properties that we talked about in the previous lesson, but in this case they have some properties that are special to them, some things that make them unique, and therefore we give them different names. So the first parallelogram that's special, that has special properties, is a rectangle, shape you all are familiar with. And the things that make it a rectangle are these two special properties. These are things that regular parallelograms don't have. So you probably already knew that a rectangle has four 90-degree or right angles. So every angle is a right angle. And it's important to know that if you know one angle is a 90-degree angle in a parallelogram, then by using the parallelogram properties, that opposite angles are congruent and consecutive angles are supplementary, you would then know that all of them are right angles. So if you know one is 90, then the rest have to be 90. Another thing about rectangles is that the two diagonals are congruent. So if you know the length of one diagonal, then you'll know the length of the other. And remember, the diagonals are segments that connect opposite vertices to each other. So one right there and one right there. They still bisect each other, but they're also congruent. So the entire length of the two diagonals is equal. It also means that these four little pieces will be equal. So all four of those are equal. And you should see that that gives us four isosceles triangles in here. Another special parallelogram is the rhombus. Again, I don't think I'm surprising you with any of these shapes. Maybe the first time though you talked about their special properties. So a rhombus is a parallelogram. What makes it special are these three properties. First things first, all of the sides in a rhombus are congruent to each other. So in this rhombus down here, all four sides are congruent. In this case, the diagonals of a rhombus, let me just draw those in here. The diagonals of a rhombus are perpendicular, so that means they intersect and they make four right angles right here in the middle of the rhombus. Another thing that the rhombus's diagonals do is that in each of these four angles of the rhombus, these angles get bisected, so they're cut into equal angles. So remember that parallelograms' opposite angles are congruent, so that means that these two angles here that are formed by this diagonal bisecting this angle, they're also congruent to these two angles here formed by the diagonal bisecting its opposite angle. In similar cases shown here, those two angles are congruent because they are bisected, and they're congruent to these two guys. So lots of things here that we could ask questions about using these properties. The last special parallelogram, again, another one you should know, is a square. The most important thing that makes a square is that it has all of the properties. It has all of the parallelogram properties, so the sides, the opposite sides are congruent and parallel. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. They also have all the properties of a rectangle, which means their diagonals are congruent, and they have four right angles. Again, that's something you already knew. It also has all the properties of a rhombus, so all four sides are congruent. Also, the diagonals are perpendicular to each other, and the diagonals also bisect the angles. So what we end up with here we end up with, if I draw my diagonals in, all four of those are the same. I end up with, again, four isosceles triangles. Each of these angles are 45 degrees. And also an interesting thing, if we cut a square in half, so I'm going to draw a new square, a smaller square. If I draw just one diagonal of this square, if it'll let me, what I end up with is two 45, 45, 90 right triangles. So a lot of times we like to draw one diagonal. We like to give you the measure of one side of a square, and we like you to find the diagonal length of the right triangle form. So even though I said we were out of the triangles unit, we were getting away from triangles, boom, there they crop up again. And you can actually use trig, you can use special right triangles. So all these shapes are kind of mixed together, but in this unit, the important thing to know here is that a square has all of the parallelogram, all of the rectangle, and all of the rhombus properties. Again, some flashcards, something that you can use to help you remember the differences between rectangles, squares, rhombuses, or just plain old parallelograms would be really helpful. And in fact, you can use them in place of just regular notes if you want to. So it's important to be able to determine, when we have a parallelogram, what's the most specific name we can call it. So if we know it's a square, we want to call it a square. We don't want to call it a rectangle or a rhombus. We want to call it a square because then we know it has all of the properties. If we know it's a rectangle, we want to call it that. We don't just want to call it a parallelogram. So a lot of times if we know just one piece of information, we can determine what the best name for that parallelogram is. So in this first example on the left, I told you that AC, which is one diagonal, is congruent to BD, which is another diagonal. So I got to go through and I got to think about which of my quadrilaterals I've talked about have that property that both diagonals are congruent to each other. I know it's not a rhombus. I know it's not a regular parallelogram. So now I have to determine whether or not this thing is a square or a rectangle, because in both, diagonals are congruent. Well, I don't have any other information in this picture to tell me that this thing is a square. So the best I can call it is a rectangle. So we can call this rectangle ABCD. Over here, I have two diagonals, and it looks like they're making a right angle. Now that happens in a square, and it happens in a rhombus. Again, in this example, I have no other information. There's nothing else drawn on here. There's nothing I'm told. Nothing else to tell me that this shape is a square. The only thing I know is that it must be a rhombus. Because in a rhombus, the diagonals are perpendicular and they give us right angles. So I want you to try these. I want you to take these figures and I want you to name them with the most specific name. So go ahead, you need to use all your properties and figure out what the most specific name you can give each of these.